So you all should have your marking pens in your hand. Pay attention to what we're doing. So we had 203, number 16. Let's take a look at this one. 16 said, I want to evaluate A plus 9 over B when A is equal to negative 4 and B is equal to negative 6. So all of you should be looking at number 16, please. All right, I'm going to go ahead and substitute these in. I typically put negative numbers in parentheses just to show that they're negative. That's not a requirement, but sometimes that can solve a lot of issues of misunderstanding what you've done. So that A is a negative 4 plus 9 divided by negative 6. All right, well, negative 4 plus a positive 9 is a positive 5 divided by a negative 6. So I could write this as negative 5, 6. And 16, negative 5, 6. It doesn't matter where the negative goes. Typically, it just goes out in the front. But if you left it as 5 over negative 6, that's fine with me. Does that help you? Awesome. What else can I do? Romano? 36? All right, 36 said I have 3 times m minus 11 divided by n when we have m is equal to 7 and n is equal to 14. Is this the one you're talking about? Awesome. All right, so I'm going to go ahead and substitute these in. So I have 3 times 7 minus 11 divided by 14. All right, so I end up with 21 minus 11 divided by 14. 21 minus 11 is 10 divided by 14. Well, 10 and 14 have a common factor of 2. The 10 becomes a 5 and the 14 becomes a 7. So this is simply 5/7, and I hope that was our answer. Yep. Does that help you? Oh, okay. Okay, excellent. Oh, you did use the right book. Okay, Kira. You can do adding the opposite. That's fine. This is just a straight 21 minus 11. But I don't have a problem with you doing it on the opposite, for sure. Pierre. 18. Excellent. So if I take a look at 18, 18 said my expression is 2 times A plus B divided by 20. And A is going to be equal to negative 4 and B is going to be equal to negative 6. Is this the problem you're talking about? Awesome. All right. So here I would definitely use parentheses to put your negative number, or to put your values in, but particularly your negative numbers. So 2 times negative 4 plus negative 6 divided by 20. All right, I like to put my negative numbers in parentheses even when I have multiplication or addition, just to show that I have the negative that's with it. It doesn't get lost. So 2 times negative 4 is a negative 8 plus negative 6 divided by 20. That's a plus. So this is negative 14 over positive 20. They both have a common factor of 2. 14 becomes a negative 7. 20 becomes 10. So I have a negative 7/10. Does that help you? Awesome. I hope as I'm going through these, first of all of you are paying attention to what I'm doing. And secondly, you are making sure you have the right work, even if you got it right. And if you got it wrong, that you found your mistake. All right, what else can I do for you? You guys good? Okay, put this away, get your notes out. are switching gears. We are going to be dealing with exponents now. All right, so today is January 14th. We are doing Chapter 4, Section 7. The title of this is Exponents and Multiplication. This section is the beginning of what I call our power rules. All right, and we're going to be focusing on our multiplication power rule. Okay, so I'm going to show you, I don't always show you why something the way it is without expecting you to do all the work. Here I'm going to show you how we come up with this power rule, but then I'm going to show you the formula that goes with it, and you don't need to do all the expanded work. Does that make sense to you guys? All right, so what I want you to do is I want you to write down 7 squared times 7 to the third. All right, this is called exponential form because it's written with exponents. I'm going to write this out in expanded form. I'm not expecting you to write it out in expanded form every time, but I want you to understand why the formula is what it is and why the rule is what it is. What does 7 squared mean? Kira? 7 times 7. I'm going to put a big multiplication symbol in there so you can see the difference between those. Layla, what does 7 times 3 mean? Or 7 to the third mean? Excellent. Are you guys all good with this? So I just wrote this multiplication out in expanded form. If you notice, all there is multiplication. So if I was to rewrite this back in exponential form with only one base and one exponent, what would you say is the exponential form? Mateo? 7 to the 5th power. So let's see if we can avoid having to do all of this expanded form and see if we can come up with how we got from the original multiplication to our final exponential form. So if I take a look at 7 squared times 7 to the third, well, what we have here is we are multiplying two terms with the same base. What value in this is our base? What does that mean they have the same base? Romano?
7.
Yeah, they both have a base of 7. Okay, so I'm multiplying two terms with the same base because this works for if you have variables as well. Okay, I'm going to write equals, and then I'm going to write equals over here, and I'm going to leave that gap in there to figure out what mathematically we could do. And I have 7 to the 5th is my final exponential form. Well, tell me something. How could I get from 7 squared times 7 to the third to 7 to the 5th? What could I do with those exponents to get from here to here? Mia? You do. You add the exponents together. So I keep the base and I add the exponents. That is our rule. All right, so here is our rule number 1. This is when we multiply terms with the same base. We keep the base. We add the exponents. So if I was to write like a generic formula, I have a to the n times a to the n, a to the m times a to the n is equal to a to the m plus n. All right, and this only works because we have multiplication. Okay, it's because we are multiplying. If we were adding, it does not work. This is because we are multiplying. So let's just go through a bunch of examples. So I'm going to put a big fat circle around this. Okay, I'm not looking for you unless they ask you to write it out in expanded form. I'm not looking for you to use expanded form to simplify these. I want you using the power rule. So from here on out, we're going to use the power rule to simplify expressions. That's what I want you paying attention to. I'm not looking for you to do the expanded form. I just wanted you to understand why we are doing what we're doing. And if you can't remember the rule, you can always fall back on the expanded form if you need to. All right, so let's practice a bunch of these. Who needs to see what's up there? Okay. I'm going to take a bunch of notes on this as we go along, just kind of random notes to remind you of stuff, so please make sure you're taking the same notes I am. If you're someone that likes color, get different colors out to help highlight, with your main notes being in pencil like we usually do. All right, so I want to simplify. Here's my first example. 3 times 3 to the third. I'm multiplying two numbers with the same base. Well, first of all, what is my exponent on my 3? What is my exponent on my 3? And let me give you a hint. It's not 0. What's my exponent? Angela? It is a 1. This is 3 to the first power. So somebody tell me what math I'm going to do to simplify this using my power rule. Frankie? Not times. I keep my base. What do I do with my exponents? Go back and you add them. So that's a 1 plus 3, right? So what is this written? Finish simplifying that. 3 to the fourth power. So what we want to do is, this is exponential form. To simplify by doing the math. So I need to do 3 times 3 times 3 times 3. So I need to see anything over a power 2, I want to see your work. So if that was 3 to the second power, obviously you can do that on your own. Anything over a power of 2, I want to see you writing it out. Over off to the side, not inside your math. So 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. So 81, that is what we call standard form. And that is simplified. So our numbers, we are going to multiply them out to simplify them. If they say write your answer using exponents, we would leave it as 3 to the fourth power. Does that make sense to you guys? Okay, I'm going to give you a couple to do, and then I'm going to make them a little bit harder. Questions on this so far? Okay. M to the 5th times m to the 7th. All of you do that, please. Use the power rule, please. You don't have to write down the power rule every time you use it. You don't have to write the power rule down. That's a little bit different than I normally do, but I want to see you writing it. I do want you kind of running down your page when you're doing these. They're going to be easier to follow than going across your page. And when on your homework, you'll have room to make corrections. So somebody use my power rule in this first step. Jack? And then what's the final? Excellent. M to the 12th power. How many of you guys got that? Okay. Let's do another one. Let's do x to the second times y times x to the third times y to the fourth. All right, my note for you on this one is, and this is a requirement of mine, move like terms next to each other, then simplify. So I want you moving the things that are like terms next to each other and then simplify. So what does that mean here? What are my like terms here? Michaela? X cubed and x squared. What else? Yes, please. Excellent. God bless you. So move those next to each other. God bless you. Remember, you don't have to show multiplication between variables. They automatically are being multiplied when you have them touching each other. So I just moved the like terms together, and now go ahead and simplify. When you're done, check with someone sitting next to you. Okay, someone tell me what to do here. Now that I've moved them next to each other, what do you want me to do? Emerson, what should I do? Excellent. Well, so these are the x and these are y. So they have different bases, right? So I have x to the 2 plus 3, and then times y to the 1 plus 4. Does that make sense? Yep. So make sure you recognize they have different bases. All right, so I've got to multiply my x terms, and then I have to multiply my y terms separately, because they are different bases. So when I do that, I get x to the 5th times y to the 5th. Does that make sense to you guys? All right, so this works because we're multiplying terms with the same base. All right. Let's take a look at some more complex ones. Questions so far? Romana. Say that one more time. Yes. So everything I'm showing you here is required. So I want to see the step where you're showing me you're adding. I know that seems very redundant, but there are several power rules. So I'm making you guys stop and think about, okay, this power rule, when I'm multiplying two numbers with the same base, I've got to add the exponents I'm showing adding. When we're dividing, that's a different one. When we have a power of a power, that's a different one. So I want you really thinking about in your brain, oh, on this one, I have to add them. So you're showing the adding, okay? All right, it's a great question. All right, so let me make them, I like these. So on a homework quiz or a test, you're going to have some that are like harder. right? Because it's like a puzzle. I kind of like these, but if you know what you're doing, you just do one thing at a time, and they're not hard at all, all right? So I want you guys to simplify. So I have negative, here's my example, negative 2x squared times 3x to the 5th. Again, on this one, you need to make sure you move like terms next to each other, then simplify. So all of you do this. And on your numbers, you're going to actually do the multiplication on those numbers. So please make sure you're paying attention to the work that I'm expecting to see. Everything that I'm showing you here is what, other than that expanded form stuff at the beginning. Everything on these examples that I'm showing you is all that I am looking for you to do. So when you're done, check with someone sitting by you, see if you guys got the same simplified answer. All right, somebody tell me what to do here. What's my first step in this? Kira? How many of you guys agree with her? Yeah, absolutely. Now, do my multiplication. Awesome. Sweet. Nice job. Questions on this? Frankie? This is the only way that you're doing it. So you didn't do it a different way. You just did the steps and you just did them in different order. Okay, so did you move the values next to each other? Okay. Listen to me carefully. Did you move the like values next to each other before you did anything else? Okay, did you read that? I don't know what to tell you. I don't know how many times I have to say the same thing. The work I'm showing you is the work I'm expecting to see in the order that I'm doing it in. My job is to give you all the knowledge I have in the best way possible for you to be successful. Your job is to listen and take the notes that I am giving you. If you're choosing to not take the notes I'm giving you, then you are choosing to not be successful. Do you understand that? So, what should you do right now with this example? Yes, do it the right way. Write this down. I'm not writing notes down for my health. I'm writing it for you guys to take so you can learn this correctly. Do you guys understand? Do all of you understand that? So if you're not taking full notes like Frankie, I can't help you be more successful than I already am. I can't make you take good notes. That's your responsibility, not mine. All I can do is give you the best notes I possibly can and the best assistance and direction and instruction. Okay, I'm going to give you a couple examples I want you guys to work on. So the directions are the same, it's simplify. So I have 6a to the third times 3a. There's my first one. And I'll put a couple more up there, so get going on that one, and then you can start working on the rest of them. So has everyone written down the first one? All right, I'll shift it up so you can see the second and the third. Who's still working on these three? Awesome. All right, we just have a couple minutes left. So let's go ahead and get started on that first one, and then if you're not done with the second or third, we'll catch up to you, or you'll catch up to us. All right, somebody do this first one for me. Aaron. So a to the third times a, right? Okay, keep going. Okay. A to the, well, I don't know what math you did to get a to the fourth. You can't skip that step. What did you do to get to a to the fourth? So a to the 3 plus 1. You guys, that is required. That step is required. Do not skip that step. And I do agree with you, it's 18 times a to the fourth. But you have to show the step of using the power rule, please. Excellent. How about the second one? Who would like to do that for us? All right, Mateo, you're up. Awesome. Wait. Do the numbers here for me. So what's negative 15 times negative 3? I'm sorry, negative 5 times negative 3. So that's 15 times 2. Okay. I want to see you multiplying two numbers at a time. Not all of them at once. Okay, so show me that you multiply negative 5 times 3 to give you 15, and then still times 2. Now, Mateo, do my variables. All right? So I have 30 times c to the 8th. Your coefficient should always come first before your variable. So although c to the 8th times 30 is the same thing as 30 times 8 times c to the 8th, math usually, the rule is you put the coefficient before the variable. All right? Excellent work. Someone do that last one for me. Vincent? Okay. Excellent. 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 And then off to the side, you did that multiplication. So 1, 2, 3, 4, 5. I need to get rid of that one. So when I multiply that out, that's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Is that what you got, Vincent, was 32? Awesome. So I have 32 times x to the 7th. How many of you guys got that? Questions on this process? Please make sure you understand I have to see that step in you using the power rule, please, showing that addition, okay? All right, you guys are good to go.